All right, so let's join. All right, you're all welcome. Sorry, few minutes behind schedule. I was just trying to set up my board very well. So today we're trying to follow the JAM syllabus. All right, those beginning topics, those ones that appears to be elementary, and I'm leaving them out for now. Okay, so I think this is the third syllabus. This is the third syllabus under JAM. Work done. Work, energy, and power is always going hand in hand. But for this class, for tonight's class, I'm just going to take work. So what we have on the left hand side of the board is basically the summary of everything I'm going to be explaining. And then the right hand side is actually where we're going to be solving questions. Okay. So please, I want to officially welcome us to tonight's class on physics. So if you can hear me, please, I would like you to type on the comment section or the chat box. Yes, I can hear you, so I can start immediately. Once again, you're welcome. So please, if you can hear me, just type on the chat box. Yes, I can hear you, sir. So we can proceed. From time to time, I'll be coming to check the screen to be sure that everything is in order because I'm using my back camera. Thank you. All right. Thank you for that. Now let's start. Now, what is work? Right? I'm just going to go straight to the point without, plenty talks. Where we need calculations, I'll give us. Where we need explanations, I'll give us. So this class is just straight to the point. Now, what is work? All right. Now, work is said to be done when a force moves an object through a distance. For example, if you're carrying a bucket of water from the ground, you're doing work because you're applying a force to lift up the bucket, right, from the ground to wherever you are. So there is a distance. Now, if you finally lift up the bucket and hold it, at that point, you're not doing work. So anytime work is said to be done, there has to be force applied and there also has to be a distance. So if you lift up something from the ground, there is a force applied. If you lift it up from the ground, there is a distance, right, from the ground to wherever you're going to suspend it. So that is basically what we talk when we say work is done. There has to be force, there has to be distance. Without force and distance, you cannot say work is done, right? So for you to say work is done, check, is there force? Is there a distance? Okay, so let's look at the summary of work. Okay, so we have different ways questions can be asked. So instead of us to be, if you open your textbook has a lot of explanation here and there that is capable of causing confusion, but I summarized everything here. The first one is work done. If you notice, here I said work is said to be done. So work is said to be done when there is a force and a distance. Now, when you now say work done, right, the force and distance will now come together. So we say work done is simply a product of force applied and distance moved by the force, which is what I just explained. Right? If you're actually pushing a chair from let's say, for example, you want to push a desk and that desk is very heavy. Many of us, we are fond of dragging chair on the floor. So you actually pushing it, you are applying a force in the direction, that chair is going to move in the direction of the force. So number one thing I would like us to note is that mathematically, what is the expression of work done? Because this is physics, there has to be some form of calculations. In as much as the definition aspect or the theoretical aspect is important, you cannot, not talk about the mathematical aspect. So work done is force times distance. There has to be force and there has to be distance. In other words, please note this formula number one, because I'm going to give us a question. When I'm done explaining this formula, I'll give us a question and I will ask you which of the formula we're going to use. So this is formula number one. Now, the next one is when a force applied and distance is expressed graphically. For example, I have something like this. Here is a force. Here is distance. And we have something like this. And here is, let's say, 10 meters. And you're being asked to actually find the work done No, ma, I already told Precious I'm having a meeting. I'm having a meeting. In case they take light, I don't want to be offing it. Okay. Thank you, ma'am. Sorry, that was interruption. My gen is on, so NEPA just brought light. I don't want to put off the gen in case they take the light again. So what I'm trying to say is that this is the first formula I want us to note. Take note of this formula. The second form or the second way question can be asked is when the force applied and the distance is expressed graphically. Anytime you see this is a graph. Anything that has y-axis and has x-axis, you can equally call that a graph. So whenever a force applied and distance is expressed graphically, which is this, work done is determined by finding the area under the graph. Now, what do I mean? If they give you something like this, they say, for example, what is the work done of a force on an object if the object moved 10 meters? Please look up. Now, this is it. Let's say, for example, how do you solve this? This is 10 meters. You trace this to this point. You ask yourself, what is the shape of this? From here now, what is the shape of this? Please look up. So if you remove this, remove this, remove this, this becomes a trapezium. This is a trapezium. So for you to now find the work done, you're going to say the area of a trapezium. Whatever the area of a trapezium gives to you, that becomes the work done. Why? Because from here, the shape of this graph is now that of a trapezium. We are going to look at that shortly. It can be that of a triangle. It can be that of a circle. So this is point number 2. Remember, all of this, we're going to be taking questions 2, 2, or 1, 1, so that at least you get to see how JAM can twist their question. So once we are done with this and you perfectly understand it, no matter how they want to twist questions, you catch them. The third one is, if the applied force moved an angle theta to the horizontal. Let me show you something. So let's say, for example, I have this is a load, and then this is force. Now, if you have a bag of rice that has a rope attached to it, and you're dragging it, that rope is going to go in this direction. So there is an angle theta. So this force is making an angle theta to the horizontal. So how you're going to solve for this is totally different if the force was in this direction. If this is a load and this is a force, this is a case whereby you want to drag a bag of rice, you squat. Now, squatting down simply means you're bringing your height in such a way that the rope you're using to drag it will not tilt up. So here, you're going to use force times distance to calculate your calculation. But anytime the force that is dragging the load or the applied force is inclined at an angle of theta to the horizontal, the formula you're going to use for that is this formula. I want you to take note of the formula because we're going to be solving an example. Now, you're dragging a rope and you're applying a force in such a way that the rope is not horizontal to the force, but the rope is inclined at an angle of theta. For you to find the force or the work done, you're going to use this formula. And the last one we would like to talk about here is if the force is moved, if you're actually moving something vertically, vertical distance is height, horizontal distance is distance. All right. So anytime you hear height, height is vertical distance. All right. Anytime you hear distance, we are talking about horizontal. So anytime a applied force is actually moving something vertically, how do you solve for the work done? MGH. So I haven't given us these four formulas or these four different ways question will be asked. I'll put out the first question on the board and you will tell me based on what I have done here, the best formula I'm going to use to solve for that. So this is my past question. I said, in the figure below, the work done by the force of 100 Newton inclined at an angle 60 degrees. Hey, sorry, my board is. I'll fix it tomorrow. All right. Now, please look at the question. Remember I said, look at this. Yesterday when I treated isotopes, I gave us all the formulas we need to carry out our calculation on one side. That is how I do my teaching. I put my formulas one side and I put question one side. So all what you just need to do for me is when I give you a question, you look at the left hand side and tell me the formula that best suits that particular guy. So look at this. We cannot use the first one. We cannot use the second one. If you look at the third one, they said, if the force applied move at an angle theta to the horizontal, which is what I just explained. Now, this is the force. The force in a rope, the rope is being dragged up, but it's making an angle theta to the horizontal at 60 degrees. So the formula I'm going to use is this. Theta in this case is 60. So I'll say Theta solution, theta is 60 degrees. Now, if in the figure below, the work done by the force of 100 Newton, force is 100 Newton. At an incline at angle of 60 to the horizontal, theta is 60. Move a distance of s equals to 8 meters. You're asked to find the work done. For the singular fact that this object, which is the load, was dragged in such a way that the force in this rope made an angle of theta. Class, for me to solve the work done, just straight to the point, no need to stress. Remember this formula. F cos theta. Now, if you want to know how I derived this formula, after this class, I'm going to be sending the video in the group. Yesterday, after the class, I sent in a video this morning, this night. After this class, I'm going to resend another video that you can watch and see how this formula was derived, right? But for me, you don't really need to start stressing yourself on how it was derived. Just know how to use the formula. So from this now, I'll come here, I'll say, anywhere I see my F, I'll put 100 because that was what was given to us. Cos theta, theta is the angle, I'll put 60. The length is 8, that's the distance. Cos 60, 60 and 90 are special angles. Cos 60 is 0.5. Sin 30 is also 0.5. So you need to take note of these special angles because JAMB always uses them because students are supposed to know them even without using calculator. So cos 60 is 0.5. 0.5 times 100 is 50. 50 times 8 is 400. So please, if you understood this calculation, please drop a thumbs up. If you don't understand this guy, drop the part you do not understand and I'll be very delighted to re-explain it again. Yeah, don't worry, we're going to use questions to explain all of them. Please, if you understood what I just solved, just drop a thumbs up. If you need more explanation, just drop where you need explanation. I'm trying to make it so explicit. So we're going to be solving questions using all those formulas. So just in case you're just joining us, you're welcome. Okay? Please, I want to clean this. I want to clean the board so that we look at another question. I believe I can clean the board. You can screenshot it and then write it out. All right. Now we have this question here. This question is a very logical question. I purposely decided to ask us this question. Let's also use it to build our confidence. Class, anytime a question is given to you, be it in chemistry, in physics, or in mathematics, first in mostly physics and chemistry, always write out the parameter. What is given to you, write it out. What is not given to you and you're asked to find, also write it out. It is based on the parameters that you have that you'll be able to tell the formula you're going to use to solve it. Okay? If you go to somebody's house and somebody brings gari and soup, it's not somebody that will tell you to go and stand up and wash your hand. If you go to somebody's house and you see rice, apparently you're going to look for spoon. So based on the meal that you're being served, of course, you're going to look out for what you're going to use. So if they give you a question, always write out the parameters. Now the question says a constant force of 40 Newton. So I'll say solution F is 40 Newton acting on a body initially at rest. Now this question here, okay, is not just conventional work done question. I want to give us something that most likely you see in JAM, not force time distance. That is SS1 work. It's still possible, but let's drill our minds a bit. They've given us force. They now said initially at rest. Anytime they say something is at rest, it means it is not moving, right? Once we hear something at rest, it means that thing is not moving. Okay? It means initial velocity, right, is zero, because velocity is actually what, if a body is moving, right, how fast the body is moving is measured by the velocity and also acceleration. Initially at rest, I will say U equals, but let's leave out this guy. Let us see if they'll give us distance, right? We have gotten force. Based on the first formula, we have gotten force. So once we get the distance, we will get our work done. So let's complete the question and see if distance is given. Acting on a body initially at rest gives an acceleration of 0.1 meter per second squared for 4 seconds. Calculate the work done. If you notice, they did not give us distance, but they gave us initial velocity. However, they did not mention initial velocity. But anytime they say a body starts from rest, rest simply means initial velocity was zero. That means that stuff started moving from that spot, right? It was not moving and then increase its pace. No, it is starting to move. So at rest, initial velocity is always equals to zero. They gave us acceleration to be 0.1 meters per second square, and they gave us time to be 4 seconds. Now, guess what? What are we looking for is distance. If we are able to get distance, it simply means we are good to go. Please, if you understand what I just explained now, or if you have any question, please, before I proceed, please drop it on the group. I'll drop it on the comments. If you have any question, I'm coming to check the comments. Now, if you have any question, please Drop it on the comments. Let me re-explain if there is any need for that. Okay, Antonia Marachi, please, I'd love to know, did you start the class with us? Yeah, if you started the class late, I'm pretty sure you may not really follow. Anchor Entertainment, did you start the class with us, please? I'd love to know. Please don't be coming. Yes, yes, yes. Are we going to look for the distance, then look for work done after? Yes, exactly. That is the deal. That is the deal. Someone has said something very nice. Now, someone has said something. Yeah, so we are going to look for the distance. Once we've gotten the distance, work done is first time distance. Since they did not give us any angle, if they had given us angle, we would have come to use the third formula. If they did not give us mass, we would have used this one, but we can see force, so we can use this to find the distance. And how can we do that? The body was moving horizontally. So anytime a body is moving, listen, once something is moving, it's on motion already, right? Once they said a body initially at rest gives an acceleration of 0.1. That means it moved from where it was. Something was initially at rest, it moved from where it was. So there is a motion. Motion is simply change in position, right? I was initially standing here, I moved to this place, right? That is motion, movement. And in physics, we have different equations of motions, right? Now, if you could remember, we have V equals to U plus 80. We also have V square equals to U square plus 2AS. We have S equals to UT plus 1 over 2 AT squared. Remember, why are we needing equation of motion? Because it was initially at rest and started accelerating. That means it has moved from where it was and started moving. So automatically it's in motion. It was in motion for 4 seconds. So for the fact that it was in motion, it covered a distance, right? So if we can get that distance that was covered, we already have our force. Automatically we can get the work done. Now, since it was on motion, for us to get the distance, we need to actually apply equations of motion. And this is the 3 equations of motion. The first one is out because the first one does not have distance in it. We are looking for distance. This one has V is final velocity, U is initial velocity, A is acceleration, T is time. So this is out. Why? Because there is no distance. The second one has distance. Distance is S, but they did not give us final velocity. This U is initial velocity. It was not mentioned in the question, but it was given. How was it given? The moment they said the body started at rest. Once anything starts at rest, initial velocity is equal to 0. So this guy, we know this one to be 0. They gave us acceleration. Now, S is what we are asked to find, but we do not know V, final velocity. So I'm not going to use this. So the best formula I'm going to use to find my distance is a third formula. Why? Because S is what I am asked or what I need to be able to get the work done. U is initial velocity, which was given to me to be 0. T is time, which was given to me to be 4 seconds. A is acceleration, which was given to me to be 0.1. And T is time. But since the body started from rest, U will be 0. So anywhere I see U, I put 0. So S now becomes 0 times T plus 1 over 2 into acceleration is 0.1 and this guy is 4 squared. So this is 4 squared is 16. I don't have calculator, so I want to do it offhand. So this is more like saying 1/2 times 1/10. 0.1 is 1/10 times 16. 2 into itself 1, 2 into this 8. 2 into 8, 4. 2 into 5, 2 into 10, 4. So we now have x equals to 4/5. Please help me press your calculator and confirm 4/5 for me. Yes, Chini, you're correct. When we see a question like this, yes, we have to look for the distance before we solve. Please, someone should press 4/5 for me. 0.8. Thank you very much. So this is 0.8 meters. So this was the distance that particular object covered. So therefore, my distance, which was initially not known, is now 0.8 meters. So therefore, work done is force times distance equals to 40 times 0.8. Please press your calculator for me. 40 times 4 is 160. Please, someone should press your calculator for me. My calculator just got bad this evening, but I'll change it tomorrow. So please, if you want me to re-explain this number 2, please put your hands up. If you don't want me to explain it, don't do anything. I'll check the comments. If you want me to re-explain this question, please put your hands up so that I can re-explain it again. Remember, I would have just decided to give us the easier ones, right? But these ones now is actually going to stimulate us to know that you need to learn more. I would have just given you a very simple one. You go to past questions, you will not be able to answer. So I'm using this one. If you understand this one, which I'm willing to re-explain it again, if you understand this, it makes it very easy for you to solve. Okay? So please, if you want me to re-explain, you just put your hands in the air. Thank you. Okay, yeah, the answer is 32. Now remember, I gave us 4 things here, but we have just solved 2. We have solved using this one. We have solved using this one. Just remaining the B and the D. Then I'll give us something to try. And with the help of after this class, you should be able to solve questions on that work. A lot of it. A lot. Please, is there any question so that I can answer, or should I proceed? Okay, someone said, how did you get that 1/10? Please, I just want to attend. Let me look at the question. That 1/10 was just me trying to use my head. The 1/10 is 0.1 is something as 1/10. 0.1 is something as 1/10. So that is how, in exams hall, I don't usually use calculator. If I'm teaching jam, most times I don't use calculator, right? Because students that I'm teaching will not be allowed to use calculator. So I try to use my head. 0.1 is something as 1/10. That is how we got that. So let me re-explain this again, right? I just want to assume that You were not here when I started. Please, for those of us that understand, just give us 5 minutes because the sole aim is to carry everybody along. Now, what are we trying to do here? We are asked to solve for work done, and I've given us the various formulas to solve for work. The first one is work done is force times distance. Now look at this question. They said a constant force of 40 Newton acting on a body. So let's say this is the body, right? Initially, this body was initially at rest. Which means the body was not moving. It's more like a stone that is actually, in one side. It's just like a stone that is placed in one part of the compound. A stone initially was at rest. Then all of a sudden, it gives an acceleration of 0.1. That means once it gives an acceleration, it will move from this position. So let's assume this guy now moved here. Now the distance now is from here to here. Or let's say that's the distance. Now it moved from here to here for how many seconds? Time equals to 4 seconds. The acceleration A equals to 0.1 meters per second. Now, they said calculate the work done. First thing first, once you hear work done, the first thing that should come to your mind, force times distance. That is the formula for work. Now, you look up. Did they give me force? Yes, 40 Newton. Did they give me distance? No. So how do they expect me to solve for work done when they gave me force and they did not give me distance? You now say, oh, but they gave me time to be 4 seconds. They gave me acceleration to be 0.1. And they said the body initially at rest accelerated. That means the body changed position. It moved from where it was. And for the singular fact that it has moved from where it was, motion has taken place. Motion is change in position of an object or a body. We have linear motion when something is moving in a straight line, right? We have rotational motion when something is turning. But in summary, motion means change in position. So for the fact that this body has changed position, that means motion has taken place. And for us to also know that motion has taken place, they said initially the body was at rest. So anytime something is at rest, it means that the initial velocity, which is always represented by u, is going to be equal to 0. So it means that I need distance so that I can come back and say, and put it here and say force times distance. I already know force. All I just need is distance, but distance was not given to me directly. Instead, they gave me distance indirectly. How? They gave me initial velocity, they gave me time, and they gave me acceleration. That means I need to use these 3 parameters to find distance. After I have gotten my distance, I will now come back and put it into this formula to solve for my work done. Now, which of the formula are we going to use to solve for? Which of the formula are we going to use to solve for this distance? We're going to use equations of motion because for the fact that there was change in position, it means motion has taken place, right? And we have equations to actually use to describe motion. The first one is V equals to U plus AT. When do we use this guy? V is final velocity, U is initial, A is acceleration, T is time. The second one is V squared equals to U squared plus 2AS. The next one is S equals to UT plus 1 over 2AT squared. The big question now is, these are the three equations of motion. What do we need these equations for? We want to solve for S. So first off, look through these three equations. Whichever of them that does not have S, you cross it out. The first one does not have S. Now the second one and the third one have S. But if you look at the second one, if you look at the parameters given to us, there is nothing like V. V is final velocity, which they did not give to us. So for the singular reason that V is not given here, this one will go out. So the formula that best fits into what we are doing, is the third one. We are asked to find for S. They gave us U, initial velocity to be 0. They gave us T, 4 seconds. They gave us A, and they gave us T. So I'll now come here and say, so therefore, my S equals to, anywhere I see U, I put 0. 0 times T. 0 times T is 0. Whatever you multiply by 0 remains 0. Plus 1 over 2. What is our acceleration? 0.1. What is our time? 4 seconds. But you have to square it. 0 times C becomes 0. So S becomes equals to 1 over 2 times 0.1 times 16. 4 squared is 16, and S becomes 0.8 meters. So we have gotten the distance to be 0.8. You now say, so therefore, my distance is now 0.8 meters. So since I have gotten distance, it's now very easy for me to now say, I'll now say, so therefore, work done equals to force, which is F, times distance, which is S. And what is my force? 40. And what is my S? 0.8. And that becomes 32 joules. I believe for those that were initially confused, I think this second explanation would help us to understand it better. All right. Please, if you understand this, to be very sure at least I'm teaching people, can you just say, yes, I understand in the chat box? That is the only way I know we are following. Okay. Please, those of us that raised up our hands earlier, is it better now? Okay. Okay, someone said, sir, please take question. That's what we are doing. We are taking it one after the other. Now, one thing I'm going to promise you is that I take question serially so that I don't miss anyone. The mistake most of us make is that you don't really know how to approach questions. So if like what I have done now, right, you can know that, oh, Mr. Delzi once taught us that, okay, we have 4 sections. So if you see any question under work done, you try to see, will this first formula be the best? Will the second be the best? Will the third be the best? But you must first of all know it inside your mind or inside your head. But many of us, I wouldn't say it's not your fault. Maybe you were not exposed to that. You do not know how to arrange stuff in your brain. If you learn how to arrange stuff, it makes it very easy. You can see it's practical. The first question I say use this formula. The second question I say use this. The third one I'm about to solve now is going to be for this number 3, this B. So let's go. We have a question here. I'm trying to solve questions at least one. And I can assure you that if you at least understand how questions can be asked, at least this one questions we have solved, you should be able to attempt lot and lot of questions. Right? Then after this class, tomorrow I'm going to resend you guys to the group, those that have paid. I'll send to the paid group questions under work. Something you can just, exercise some, brain energy. At the end of the day, I will still send in the correction. So you try and then you look at the correction. Automatically, you grab it. You close the chapter for work. Tomorrow, we are ending everything about work. And we are moving on to the next topic. Every day, you should be learning 2 to 3 topics. Okay? Now, we have a question here. Remember I said, anytime, look at what the second one says. When a force applied and distance is expressed graphically, work done is determined by finding the area under the force distance graph. Please, can you hear me now? My mic went off, so I had to change another mic. Please, if you can hear me, indicate. Please, can you hear me now? My mic went off. Can you hear me? If you can hear me, please indicate in the comments or in the chat box. Okay. Thank you. I love you guys' energy. Okay. It's giving me the vibes of teach till 11 p.m. Now, look at this. That's why I keep checking my mic. I don't want a case whereby I will spend hours explaining and then the mic is off. Maybe I'll just be holding it in my hand so I can be checking it out. They said when the force applied and distance is expressed graphically. Remember I said anytime something has y-axis and has x-axis, that is a graph. So anytime you have something in a graphical form and you're asked to find the work, all you just have to do is to look at the shape of the graph. Whatever the shape of the graph is, find the area of that shape. That becomes the work done. Now, how do we get to know? Look at this. Work done is determined by finding the area under the force distance graph. If you look at this shape, this is a semicircle, right? So look at the question. A body is under the action of a force F such that the force displacement graph of the body is semicircular. as shown. The work done on the body by the force in moving 24 meters is dash. 24 meters. Look through the x-axis. Where do we have 24? Here. What is the shape of this guy from here to here? A semicircle. They even mentioned it. Now, for me to find the area of this, which is eventually going to be the work done, because once you look at the shape of the graph, if the shape of the graph is a triangle, the work done is going to be equal to the area of a triangle. If the shape of the graph is a trapezium, the work done is going to be area of a trapezium. If the shape of the graph is a circle, the work done equals to area of a circle. But if you look at this guy, this is a semicircle. And what do we mean by a semicircle? This is how a circle looks like. Now, when you divide circle into two, you have a semicircle. Now, let me walk us through this. Area of a circle, full circle. Area of a circle is equals to pi r square. That is the area of a circle, full circle. But since they said semicircle, semi means cutting the circle into two. So I will now say area of a semicircle. Area of a semicircle, please watch, is now equals to 1 over 2. That is half of the area of a circle. Semi means dividing something into two. A full circle has pi r square. A semicircle will have half pi r square. What is r? R equals to radius. Now, but from here to here, from let's say A to B, is not the radius, it is the diameter. We need the radius, but what we know here, the line that divides circle into two is called the diameter. From here to here is the diameter. So for me to get radius is the distance from the circumference of the circle to the center of that circle. Meaning that I need two radius to have one diameter. From here to here, let's call this guy the center. This is R. From here now to here again, this is R. Sorry, I need to attach this guy well. From here to here is R. From here to here is R. So for me to get the diameter, class, diameter equals to 2R, because the diameter is this line that divides the circle into two. So what I'm trying to do now, I'm trying to explain the details, but in exams you do not need this, right? What do you need in exams? Pi r square. How do you get your R? R equals to diameter over 2. That is how you get your R. So that is how you get your R. So now, how do we get the diameter? Class, look up. This, from this point to this point, it's more like the line that divided the circle into two. They said in moving 24 meters. So from here to here is the diameter. So the diameter of this guy is equals to 24. But remember, if I want to solve the area of a semicircle, it is 1 over 2 pi r square. Pi r square is the area of a circle. So for me to get that of a semicircle, I'll divide it by 2 or I'll multiply by half. So here, my r now becomes diameter over 2, which is 24 over 2. So this becomes 24 over 2, which is equals to, let's switch to this other side. I don't like the fact that the body is moving crazy this evening. So we have radius equals to diameter over 2. And what is a diameter? The distance from here to here. From what I just explained, diameter is a line that divides circle into two halves. And if you notice from here to here is what is dividing this circle, because if I come here and add this, I'll form a circle, right? So this becomes a diameter, right? So I'll make sure I fix this. It's just to get hammer and nail this bottom very well. So this is 24 divided by 2. So my radius is 12 meters. So I will now say area work done equals to area of the shape of the graph, which is area of a semicircle, which is, now normal, if the circle was not semi, it would have been area of a circle is pi r squared. But since it is semi means half. So this is 1 over 2 pi r squared. Now this is 1 over 2. If you look at the option, they retained pi. Pi was retained. So there is no need for me to solve. The value of pi is 3.142. But looking at the option, since they retained pi, so I'm just going to also keep pi. I'm not going to put the value for pi. So I'll say I'll leave pi and put pi as pi times the radius is 12. So this is 12 times 12. So this cancels this. We have 6. Twelve times 6 is 72. So the answer here becomes 72 pi joules, which is option number B. The explanation here is, it was too long. I don't like those kind of explanation, right? But let me see how many of us were able to understand what I just explained. Long explanation is not always very good, right? But I was trying to make us understand this. But subsequently, just too much explanation makes it, stressful to the brain. So if you understood what I just solved now, please indicate in the comment. Just raise up your hand or just give any gesture. If you don't understand, say I do not understand, and I wouldn't mind resolving it on this side of the board all over again. All right, thank you very much for your feedback. At least it gladdens my heart to know that we are following, despite the fact that my board was moving mad. Okay, now this is what I'm going to do for us. This last part, I would have loved to solve it, but I want us to occupy our brains. What do I mean? I'm going to be sending questions this night. Please, this is 9. This is 9:38. 9:38. Right? So I'll drop a question under this. I'd like us to solve it. Right? Or should I solve one question here, or I should just give you guys to try? I gave us 4 sections and I've done 3. And with those 3 now, you can actually go back, check your past questions and try to solve them. Okay? So what do you think? Should I solve this last one? I should just give you, because I wouldn't want the video to be excessively very long. That is why. So please drop your comments. And please, if you have not subscribed to our channel, please do well to tap the subscription button. And also, please tap the like button so that algorithm can recommend the videos to other jam bites. if we are 18 or 20, please, every one of us just type the like button so that the video can be recommended to others. It's very, very helpful. Actually, I would like to get our view here. I have a question here. Please, let's solve this last question. Still under the force displacement graph. Please look up. I just wanted to solve something else that has another shape. This one was a circle, a semicircle. This one is a triangle. Remember I said anytime you're being given a graph or force distance graph and you are asked to find the work done, the work done is simply going to be the area under the graph. What do they mean area under the graph? Look at the shape of the graph. If the shape of the graph is a triangle, area under the graph is going to be the area of that shape, which is, if this guy is a triangle, area of a triangle. This was a semicircle, area of a circle. If it is a rectangle, area of a rectangle. So in this case now, this is actually a triangle. The diagram below shows the force acting on an object through a distance of x. What is the work done on this object as expressed? Now, remember what I said? The work done for a force displacement graph is always equal to the area under that graph. So first, what is the shape of the graph? That is what you're going to ask yourself. If the shape of the graph is a triangle, it simply means you need to know the area of a triangle. Once you have gotten the area of a triangle, that automatically becomes the work done. So I'll say work done equals to area under the graph, which is in this case area of a triangle. Because this graph, if you look at it, this is a triangle. And what is area of a triangle? Half base times height. This is area of a triangle. What is a base from here to here? The base is x. What is the height from here to here, which is f, which is this guy? The height is the vertical distance. From here to here, this is the height f, which is the y-axis. The distance is the x, which is the x-axis. So this becomes equals to 1 over 2 times the base is x. times the height is f. So this now becomes equals to 1 over 2. You write the f first, f, and then you put x, joules. If you look at this option, option A is not correct. Option B is not correct. Option C is not correct. Option D is correct. Now, one of these things you're seeing fx can be rewritten to be fx divided by 2 joules. That is the answer for that. Trust me, these things you feel that they are very easy. By the special grace of God, after if I teach you for 1 month, you're really going to understand that most of the times our teachers in secondary school make these things to be very hard, right? So me, I go straight to the point. There is no need giving us notes, plenty notes. JAMB is OBJ. Once you see a question, you should be able to recall very fast. All right. So please, if you have not yet registered for our class, it means definitely you're going to be missing out. I understand many of us may want to register, but they do not have the money. Some of us are still trying to contemplate. Please, I can assure you that if you register with us full time, this is just the tip of the iceberg. This is my house. This is my room. My gen has been running for the duration of this class. NEPA light has come and gone, but I did not bother to change, right? If I wasn't really serious about this, I won't be doing it, okay? So I just want to establish myself in this online space so that I can also be very popular like many others on the online space. So that is why we decided to bring down our class fee for that amount. It's just for logistics. So if you're yet to register, please send me a DM after this class, make your payments, and I'll add it to the paid group. I'll be dropping something later this night. Please make sure you take part in all the assignments. I want to believe that we actually followed up in today's class. Please, if you have any question or any concern about today's class, please, you can drop it on the comments or you can drop it on my DM. You can still ask me question on my DM. This is my phone number. Send me a message on WhatsApp and I'll be delighted to answer you. I'll be coming to check the comment section to see if there's any question that needs my attention. Thank you. Someone said, yeah, I'll stop it for today. Chini Fair, your network was bad. Yeah, our time is almost this 70 minutes. So I'm sorry I wouldn't be able to re-explain it again. But you can rewatch this video after 20 minutes. Right? You can rewatch the video and the video will be stored on YouTube. So you can come back to our channel and rewatch it. I'd have loved to re-explain it again, but we're already behind time. All right. You can also come to my DM so I can explain it to you. So for those of us that want to make payment and join the group this night, which I will suggest so that you don't miss out, please send me a DM after this class. My phone number is on the board, right? The top right of the second board. Thank you very much. Have a wonderful night. Trust everybody. Good night.